Hello, welcome to The Exhausted Programmer. My name is Alexander, and today we're talking about how programs are made. When we have programs that run, there might be a question as to how they came into existence. How do we go from ideas in a brain into code that runs on a machine? Well, I would say that nobody really knows from end to end how that all works. In fact, even today, there's a ton of science and scientists spending a lot of money, time, effort, and research trying to understand how the brain works. So if anyone says that they do know, well, they should share it with the rest of us. On the other end, you have a CPU that only understands zeros and ones. And while it might be easy to understand the mechanics of it all, today's modern CPUs aren't even designed by one person, or one person has an understanding of how a modern x86-64 processor works in its entirety. Yes, you pass in zeros and ones that represent instructions, and you pass in values with those same zeros and ones, but the entire list of possible instructions and how the CPU itself is laid out, it's quite complicated. In fact, I've been told it's so complicated that we now leave it up to machines to optimize the layout of CPUs because it's just too much for our regular human brains to handle, or at least to do as well of a job as a computer can. No, I'm not talking about AI, more just improving distances and trying to find the shortest routes to run wires. Either way, there are basic steps that happen in this process that we can understand. Again, I'm not going to discuss the brain aspects of it all, but once you have the idea, which may exist in one person's head or may be a collaborative effort, then that has to become machine code. And that's what I want to talk about in this video. How does that happen? Well, first you have to choose a programming language. And there are a lot of programming languages, but there's certain patterns that we can follow along that generally applies to all of them. What we see here is a common line of code that could be found in a multitude of programming languages. The first thing the interpreter or compiler will do is to go through byte by byte of this file to determine what is there. Many programming languages will look at things like a space or the end of a line and use that to separate things into words or tokens that will be consumed in a logical order. In this example, there are 5 tokens or words. As the programming compiler or interpreter goes through, many of them will first recognize the equal sign and then the plus sign. A plus sign in many programming languages can serve multiple functions, but the equal sign is a little bit more restrictive. Again, in most programming languages, this would imply that you evaluate what's on the right-hand side of the equal sign and put it into the left. The difference between a programming language and normal language is that you can't flip it. You can't assume that the other person will understand what's being said. It has to follow these specific rules. Next, the interpreter probably will look at each of the words, final score, first score, and second score. You might see those as 6 words, but because there's no space between them, we can think of them as one word for the sake of a programming language. There are rules as to what can and cannot be a variable name, but since these aren't already reserved keywords in the programming language, the interpreter or compiler will assume that they are in fact variables. So they will go to a table where they have stored existing variables to determine what's what. As I said earlier, the first thing is we have to evaluate the value on the right-hand side. When the program is looking up the values in the variables first score, second score, and final score, it will also be checking to make sure that they exist and what the values are. For the sake of final score, some programming languages don't even need it to exist. It will create it at this time. Other programming languages will give an error because final score doesn't exist, and therefore it doesn't know what type of variable it will be when the evaluation is over, or what type of variable it's expected to be when the evaluation is over. But one way or the other, a variable table will be looked at, the values will be pulled, added together, and stored into final score, assuming there are no errors. While this one line of code does seem simple, I think it serves as a great example of how we go from something that is human readable to machine executable. The whole purpose of these series of videos is to make it clear that everything isn't super complicated from beginning to end when it comes to computers. But I do feel the need to point out that learning how to program is more than just knowing the keywords and tokens that are used by a programming language. There's a lot of more aspects to programming than just the language itself. In fact, I hope to do a series of videos on how to program without actually knowing how to write in a programming language, because there are certain key aspects of programming that are true for most languages, things that we can assume to be there, and anything that is considered Turing complete. But the fact is, going for something that can be read by a human into machine code is a overall simple process. And I do want to point out that once you've turned it into something that is machine code executable, that is into a bunch of zeros and ones, the original written file still stays around. And that's how code is maintained. That is, we edit the original human readable file with more human readable code and then rerun the interpreter or compiler to get out the new updated machine code. Thank you for watching.